We are going to demonstrate how to perform the consolidation test. First, we need to set up the specimen in the consolidation specimen ring. The specimen can be prepared from sample retrieved from the field. We used kaolinite for this demonstration. This specimen was prepared using a sedimentation tube. In addition, vertical pressure was applied such that the specimen can be densely packed. Now we use the jack to extrude the specimen from the steel sampling tube. Then we want the specimen to enter the consolidation specimen ring. Remember to measure the inner and outer diameters, height, and mass of the ring. There are two ends for the specimen ring. One end has a smaller diameter and a sharp cutting edge. This end should be facing downwards. The ring should be placed in the middle. Place a plexiglass plate on top to provide a reaction force. When we extrude the soil, one student should be pressing the plexiglass plate and another student should operate the jack. Now the specimen ring is filled with the specimen extruded from the steel tube. However, we would like the height of the specimen to be higher than the specimen ring because we can trim off the disturbed soil. To do that, we place another specimen ring on top. Use plexiglass plates for providing the reaction force and extrude more soil using the jack. If you look at the specimen closely, you can see that the soil has expanded once it leaves the sampling tube. Please be careful when extruding, moving, and trimming the soil because the soil property will be altered if the soil is disturbed. Push and rotate the specimen slowly to the plexiglass plate. Place another plexiglass plate on top. Now we need to trim the soil specimen such that it has the same size as the consolidation specimen ring. Slide off the top plexiglass plate. There is soil on the outside of the specimen ring. Just gently peel it off. Use a wire saw to trim the soil specimen on top of the specimen ring. Start from the side and trim the soil little by little to avoid causing disturbance to the soil. Some of the trimmed soil should be used to determine the moisture content prior to the consolidation test. Make sure that there is no soil left on the outside of the specimen ring and the plexiglass plates. Measure the mass of the specimen inside the specimen ring. Now we are going to set up the specimen inside the consolidation reservoir. We need to prepare two filter papers. The lower filter paper can be bigger than the specimen ring. The upper filter paper should be slightly smaller than the specimen ring. Add some water into the reservoir. Place the lower porous stone. Dip the lower filter paper in water and place it on top of the lower porous stone. Slide off the plexiglass plate and place the specimen ring. Dip the upper filter paper in water and place it on top of the specimen ring. Make sure that the upper filter paper aligns with the specimen ring. Place the fastening ring and screw it tightly. Place the top porous stone and the top cap. In the next 2 weeks, we are going to use the displacement meter to measure the consolidation settlement of soil. Let's discuss how to read the displacement meter. For this device, the number will become bigger when there is settlement. For the large dial phase, one check mark represents 0.002 mm. One round of the large dial phase means one check mark of the small dial phase, which is equal to 0.2 mm. This device is very sensitive. Now we place the reservoir onto the consolidometer. We then need to adjust the contact and set up the displacement meter. This plate is 0.1 kg in mass and will be used to adjust the contact of different parts of the consolidometer. However, this mass is not counted towards the loading applied to the soil. Set the loading frame in the upright position and adjust the screw. Don't need to fasten the screw tightly at this point because we only need the loading frame to be just in contact with the top cap. This consolidometer makes use of a lever system. We can observe this contact point to make sure that the loading frame is just in contact with the top cap. Adjust the screw on top of the top cap slowly. When the screw is in contact with the top cap, this rod will start to detach from the lever. Hence, you need to unscrew a little bit such that this rod will be just in contact with the lever. If all the parts are in the right positions, fasten this larger screw while holding the smaller screw. Adjust the position of the displacement meter such that it touches the top of the smaller screw. Reset the dial and record the initial number indicated on the large and small dial faces. Now we can start to load the specimen. we need to lower this rod such that the load from the loading place can be transferred to the specimen through the lever. There are 3 holes here which represent different lever ratios. The current setting has a lever ratio of 9.82. This means that if we have a 1 kg loading plate here, the specimen will be subjected to a loading of 9.82 kg. At this point, if I press onto the lever, the specimen will not be loaded because the load will be taken by this rod. Lower this rod right before the experiment starts. Make sure that no one goes near the consolidometer during the experiment unless a reading needs to be taken or loads need to be added. Now we can start the experiment. Reset the dial. Lower the rod and you can see that the readings of the dial phases are changing. Wait for 2 to 3 minutes for the reading to become stable. Today we are going to add the first loading, which is equal to 0.5 kg. Leave it for 24 hours. The next stage of loading will start after that. Record the readings on the dial phases. The readings should be taken at 6 seconds, 15 seconds, 30 seconds, 1 minute, etc. after the loading is applied. Record the readings on the large dial phase first because the change of the reading is very rapid. After 4 to 5 minutes when the reading becomes stable, we need to add water to the reservoir to ensure that the specimen will be saturated. Add the water slowly such that no disturbance will be induced to the soil. For the subsequent loading stages in the next 2 weeks, always make sure that the water level in the reservoir will be over the top porous stone. Make sure that the smaller loading plates are always on top of the large loading plates. Also, the opening of the loading plates should be facing different directions such that the loading plates would not fall off together easily.